So we are going to find the moment of inertia of this system, these two rods, about this line y is equals to x. Okay, so uh, we are going to use, actually we have two methods. Okay, so let me draw another line in the same plane as this system, and that is y is equals to minus x, and it will look like this. Now you can see by symmetry that the moment of inertia of these two rods about this line y is equals to x and y is equals to minus x will be same or equal. Okay, so what I will do is I will redraw this diagram, and then there is a third axis which is perpendicular, and like it's a z axis, it is coming out of the plane, you know, and the intersection point has to be the same for all three axes. So the two axes, so like I am going to use the perpendicular axis theorem. And what is perpendicular axis theorem? That any planar object, suppose this is a plane object, they look like an ellipse, but it is completely filled with mass, so it is a planar lamina. Okay, so two axes have to be in the same plane and perpendicular to each other, and the third axis must pass through exact same point and perpendicular to the plane. So that third axis is going to be the z axis. So what does this perpendicular axis theorem says? That moment of inertia about z axis, that is the axis perpendicular to the plane, is equals to moment of inertia about one of the axis plus about the other axis. So in this case, in our case, the two axes in the plane are these lines y is equals to minus x and y is equals to x, and the perpendicular axis is the z axis, this one coming out of the page or coming out of the plane. Okay, so now let's continue. So if I am going to find this moment of inertia about z, that is going to be ml square by 12. So the z-axis is passing through the center of mass of both the rods. So for one rod, it will be ml square by 12 for a rod passing through center, and for other also ml square by 12. Now for these two, it is going to be equal. So two times of this. So Ix, Iz, these two are going to be equal. So two times of moment of inertia about the line y is equals to x. So from here you can get that moment of inertia about this line y is equals to x is going to be ml square by 12. So these are 2, this is 2, so for 1 ml square by 12. Now there is yet another method to solve this question, which I have written down below. So it's like about a line. This is a line about which you have to find moment of inertia, and this is a rod L of mass m. So for this system, the moment of inertia comes out to be ml square by 3 sine square theta. So now let me consider that mm, I break this system above this system in 4 parts. So 1, 2, 3 and 4. So each part will have mass is equals to m by 2 and length is equals to L by 2. Now I have 4 systems. All 4 are having the same angle theta. Same angle theta with the line. This is the line. Okay. So I can use this formula here also. ml square by 3 sine square theta, where theta is equals to 45 degree. You know that the line y is equals to x makes angle of 45 degree with the x-axis. Same with the y-axis. So the angle are equal. So mass of individual rod. This is one rod. This is another. This is like 4 rods. Okay. So m is equals to m by 2, L is equals to L by 2. 4 times, because we are consider 4 rods into ml square by 3 sine square theta. So here we use 4 into 1 by 3, 4 and 3 from here, 3 here and 4 for the 4 rods. M by 2, L by 2, so it's square be L square by 4 sine square 45. So you calculate this, again the answer is going to be ml square by 12.